My understanding, whether this is correct or not, was that, and I'm sorry if this background noise is too much. My understanding is that the RRS going away from it was just because the technology itself was like much more expensive, both to produce and to
Yep.
purchase.
Mm-hmm.
But I mean, I would think the melanin in the palm versus the fingertip is similar. It's more that you can like squeeze out for the hemoglobin with the blanching. I this is a good question for Werner and Igor, I think.
And anyone else, feel free to chime in if anyone has any other thoughts on this.
Yeah, thanks for answering that. The reason I'm asking is, if we're having some issues with the finger, and and I get why you want to blanch out the hemoglobin, and the blood flow, but maybe we have to figure out a device where we help the individual apply just enough pressure so we're not squeezing their hand, because I know we're working with a lot of like preschoolers and infants too in some of these, like, so I wasn't sure if the technology got better, which is what it's I guess somewhat, but it may be worth considering. I'd be curious to see what those other newer technologies are, but I'm guessing they're made by different people, and I'm guessing those proprietors are not willing to share always their algorithms for use. So just curious, because I've used the RRS as well.
Mm-hmm. The one other device that I've started looking at, just out of curiosity, is made by a company in Germany, and their algorithms are locked down tight. Like, it doesn't even come out on their tablets in the app. Everything goes to their server in Germany, gets analyzed there, and then it pops back your score, because they don't want anything to be reverse engineered.
Wow.
Yeah.
Yeah, and I think that technology, Alicia, that you're talking about, we just saw some of the first publications come out using that. So after this call, we can circulate those articles in case anyone's interested in looking more into that. So I guess there's pros and cons, right? There's I've heard that purchasing the device might be a little bit cheaper than the Vegimeter, but not kind of knowing what's going on the back end, not understanding the algorithm that it's employing. I mean, those are some major concerns that I would have as a researcher.
Yeah. And I believe it's also being used and marketed, not that marketing for supplement purposes is problematic necessarily, but that's kind of the world that it has been created for. So to be used in a research field, it might take a little bit more discussion with the developers to make it so that it's formatted in a way that we're getting the data that we need to be able to analyze appropriately.
Yeah, one more comment in the chat. Yeah, before we transition over to Valerie. So Amy, thinking about some of the other reasons as to why the finger might be more advantageous compared to the palm and other spectroscopy measurements. So maybe less callousing. Most of the callousing is on the tip of the finger, not the pad. So another reason why we might be more leaning toward different sites for measurements. Thanks for sharing. Great. Well, if anyone here in the room has any follow-up questions for Alicia, feel free to type those in the chat. And we'll go ahead and transition to our next speaker, Valerie, before we open it up for open forum. So Valerie is a professor and the director of the graduate program at the Department of Allied Health Sciences. She offers a wealth of experience in food, nutrition, health promotion, and public health nutrition. Her research program has two major areas. First is to understand the sensory nutrition, or the influence of variation in chemosensory perception of food flavors, as well as food preference and consumption. Recently, her team has translated sensory nutrition into individualized dietary recommendations for both children and adults through online surveys, as well as tailored nutrition messaging. The ultimate goal of her lab group is to leverage sensory nutrition to encourage the consumption of healthy diets that are more enjoyable for the promotion of health as well as prevention of disease. The secondary major area of research is involved in interdisciplinary work to engage communities to promote healthy diets and weights of children and their families, particularly those from disadvantaged socioeconomic backgrounds. Today, her talk is titled Young Children and Families, Alignment of Vegemeter Scores and Liking Assessments. Valerie, welcome, and please feel free to share your screen.
Can everybody see my screen okay?
Looks great.
Well, thanks for such a nice introduction. I've changed slightly my talk a little bit. But it's so nice to be here, and I'm honored to be able to speak with you today and thank the group for inviting me. And if I don't make sense, I'd rather have you just shout out and say, hey, can you clarify? Because I hope we can get some kind of informality there. And so I just want to say that I have nothing to disclose. I'm on the faculty. I'm no longer graduate program director. Got it starting in the school year or the fall. But I am a registered dietitian, and the department that I'm in is focused on health promotion sciences. And I have multiple channels of funding from USDA, so I hope they eventually pass the Farm Bill. So I just want to make the main points is that we have found the skin carotenoid is a feasible measure in large preschool-based study, but there is a strong influence of social determinants of health, the SNAP participation, so it was harder to see a dietary intervention effect. And I'm going to show you some tools that associate nicely with skin carotenoid in preschoolers and students. And I'm going to share some of the challenges with skin carotenoids as an outcome measure for diet interventions. So the first thing I'm going to talk about is a preschool-based intervention, and this is a little old, but still. It's from funding with the American Diabetes Association and USDA Hatch. So we had this paper come out, and it reported on the baseline measures of the intervention by a doctoral student at the time, Mostane Sharifi, and our lab group in collaboration with Susan Main's group. And I see Brenda Cartmellon. So hi, Brenda. And that was when she was at Yale University. So it was quite an effort. We had 2 separate cities participate in Connecticut to recruit preschoolers from Head Start and school-supported preschools. And one city was the intervention, the other was a controlled group with a delayed intervention. And so these are data from the baseline measures and were collected during the first 45 days of the school year. And we actually used measured height and weight and calculation of BMI percentile, so about 40% were overweight and obese. So one of the dietary assessment tools we used was our pediatric adapted liking survey. In this version, it was just 2-page with 18 foods and beverages and 4 non-foods, which supported, the parent filled this out when pick up or drop off, that the scale applied to anything, not just foods and beverages, which from a psychophysics standpoint or measurement of perception is very important. And we also worked with Block to modify their kids questionnaire. And it was 41 items, 2-page, and we calculated food group intake based on frequency and portion size for calculation of a diet quality score. And then we mailed back this survey, and Nutrition Quest estimated macro and micronutrient intakes and energy intake. And at the time, it was $5,000 to do it. So it was a lot to have that process, just saying. And then we measured skin carotenoid status by Raman resonance spectroscopy. And I'm in no way an expert on this, but this is a wonderful picture of Stephanie Scarmell, who was a doctoral student at Yale University in public health. And the children really enjoy doing this. They got to wear the sunglasses, and who wouldn't like to interact with Stephanie? She was so friendly. And it was in the palm of the hand, and it was done 3 times for reliability with an exposure of 30 seconds per scan. And here is the scatter plot. It was normally distributed with just a slight positive skew, and the intra-individual variation across the 3 scans was only 5%, which is pretty good. So we did 2 hierarchical models to predict carotenoid status from the relative contribution of our simple liking scale and frequency responses to fruits and vegetables. So both models started with age, family SNAP participation, and BMI. So what I want you to notice is the pretty large total R square from those 3 factors. And then the first model tested liking, the simple liking survey, as a value-added prediction of carotenoid status. So first we entered food frequency, fruit and vegetable frequency intake, and that contributed 1.2% to predicting carotenoid status, and the liking of fruits and vegetables predicted an additional 2.8. And then the second model tested liking as an alternative predictor of carotenoid status. It added the added contribution of fruit and vegetable intake after controlling for liking was not significant. So overall, these findings suggested that simply asking the child's liking for fruits and vegetables was a stronger predictor of carotenoid status than was reported fruit and vegetable intake. So we were interested in calculating a diet quality score from the liking survey. So first, we calculated a diet quality index from the frequency-based survey based on the Healthy Eating Index 2010, and the liking survey based on a variety score, how many healthy foods they liked, and a conceptual weighting of the food groups. Both showed very good normal variability across the sample of 461 children, and the liking had an acceptable internal reliability of the index, unlike the frequency-based. The liking diet quality index also reflected more than one construct in exploratory principal component analysis, which is good. And it was independent of estimated energy intake from the food frequency survey. Also very good. So these are busy, and I apologize, but these were multivariate models trying to simultaneously assess relationships of diet quality, adiposity, and carotenoid status. And these were done by Mastane. She's an amazing, she really loved doing all of these analyses under the guidance of Tanya Hueda Medina. So the model of the frequency-based diet quality index did not achieve acceptable fit, but here is the liking-based model, and it had acceptable fit, so that, interestingly, exposure to middle ear infection associates with lower liking of fruits and vegetables, possibly because of the oral interactions, as well as food neophobia and SNAP participation, so the lower diet quality, in turn, associated with greater BMI percentiles and lower carotenoid status. And interestingly, and this is very good, another model with a latent variable of liking and frequency-based diet quality had the best fit and showed stronger associations between that latent diet quality index and BMI percentile and carotenoid status.